You just got hit with an undervoltage code. 1900, 1901, maybe 1902, and your generator shut down. Now what? Before you start swapping parts or chasing gremlins, let's slow down and walk through what these codes really mean and how to test what actually matters step by step. Most fixes are simpler than you think. These undervoltage codes usually boil down to one of three things. The field boost circuit isn't working, the rotor isn't magnetizing, or the voltage sensing circuit isn't seeing the output even if it's there. In this video, we'll follow the official diagnostic flow, but with a layer of common sense earned through years in the field. Undervoltage means the generator isn't reaching its expected output. That could be because the rotor never developed a magnetic field, or maybe the stator is healthy but the controller can't see the output, or maybe it's something simple like worn brushes or dirty slip rings. Our job is to figure out why. The field boost is like a jump start to your rotor. When you crank the engine, the controller pushes unregulated voltage from the stator back into the rotor windings to create a magnetic field. If that loop fails due to a weak boost signal or poor brush contact, voltage won't build, and that's where most undervoltage codes start. We begin with a basic but crucial test. Does the generator build voltage at all? Use the controller's display and a multimeter across wires 11 and 44, and if you're reading 0 or just a tiny residual voltage, something is interrupting field boost or the rotor isn't accepting excitation. Before we start testing, we want to make sure the generator doesn't accidentally transfer power to the house when we run it in manual mode. The manual suggests disconnecting wire 23 to prevent transfer, but in most cases it's quicker and just as effective to shut off the generator's mainline breaker, and that prevents E1 and E2 from energizing, so even if utility power is out, the transfer switch won't activate. Once the generator is running, let it stabilize for a minute and then check the output voltage on the controller screen and confirm it with your meter across wires 11 and 44. This tells you whether the generator is actually building voltage or not. I know the manual doesn't start here, but if I had $1 for every undervoltage fault that turned out to be dirty slip rings or worn brushes, I'd never touch another meter. I suggest starting your inspection at the brush set. We've just seen too many failures here not to. After recent hurricanes here in Florida, we saw a wave of generators with pitted slip rings, stuck brushes, and scorched brush wires. Some of these units were nearly new. Heat, humidity, long run times pull these parts out of spec fast. If your slip rings are pitted, voltage doesn't have a chance to build cleanly. If the brushes can't transfer clean current to the rotor, the field can't form. No field equals no magnetism, and no magnetism equals no output voltage from the stator. So while the controller's throwing an undervoltage code, what's really happening might be a failure to excite the rotor, often caused by poor contact or a broken path in that excitation loop. With the generator off, test resistance across wires 4 and 0 at the controller connector. You're checking for rotor continuity through the brush set. The exact value will vary by model, but it should be low, typically a few ohms. So if you see OL or no continuity, that points to worn brushes, damaged rings, or a broken rotor winding. If your resistance across 4 and 0 checks out, then we move to test 4, measuring voltage across wires 2 and 6 while cranking. This is unregulated AC voltage generated by the stator's excitation winding, so you should see over 50 volts AC. If you're not, the winding could be weak, or the rotor speed may be too low, or there may be a fault inside the generator's internal wiring. No field boost means the rotor never wakes up. It's like trying to build a fire without a spark. Your engine will run fine, but you won't see any output because there's no magnetism to induce voltage in the stator. Sometimes it's not completely dead, just too weak to do its job. During crank, you should see AC voltage across wires 2 and 6, often up to 50 volts or more, so if you're getting significantly less than that, there's a good chance the excitation winding in the stator is failing to deliver. This could point to a bad winding, a failed connection, or an issue inside the controller that's blocking field boost from reaching the rotor. Here's a test that I like to do when the readings just don't add up. Check voltage drop across the brushes. If you're feeding the correct boost voltage into the rotor circuit, but you're losing 10 or 15 volts before it reaches the other side, you've got brush drag, pitted slip rings, or high resistance, and that's a bottleneck that no controller or voltage regulator can fix. Now, jump to test 6. Check resistance across wires 2 and 6 with the unit off. This tells you whether the excitation winding in the stator is intact. The correct resistance will vary by model, and the values can be found in the front of the diagnostic manual. If your meter shows an open circuit or a value that's clearly outside of the expected range, that usually means a break or internal fault in the winding itself. Next up, test 5. This one gets overlooked, but it's critical. Check voltage at wires 11 and 44 with the generator running, and if the unit is producing voltage but these leads aren't carrying it to the controller, you'll still fault. The controller needs to see the voltage to know it's safe to stay online. I've seen this one fool plenty of techs, including myself. The generator runs, output is good, but the controller can't sense it and it throws a code 1900. The manual has you test resistance on wires 11 and 44 back to neutral. If the path is open or reading too high, it could be a wiring fault somewhere between the stator and the controller. Follow the test steps closely to isolate where the signal is getting lost. Code 1900 is the controller's way of saying voltage is too low or not present. Could be a real generation problem, or it could be a sensing issue. That's why we isolate tests. Rotor first, then stator, then sensing. Code 1901 usually means voltage was building, but dropped the moment the transfer switch engaged. That can point to a weak field boost, poor brushes, or a borderline rotor. As soon as the load hit, the voltage collapsed. If you get a code 1902, you likely had no output voltage at all. Not low, zero. That points straight to the excitation system. The controller tried to build voltage, but nothing happened. Code 1906 means the controller is only seeing one of the two AC waveforms. This usually comes down to partial excitation or instability in the output. Could be one brush is barely making contact, or corrosion is disrupting clean waveform sensing. Now, let's wrap up with one more, code 2299. You don't see it often, but when you do, it usually means the generator got slapped with load before it finished ramping up voltage. Code 2299 shows up when the generator tries to start under heavy load and can't reach full voltage. The most common reason, the automatic transfer switch put the house on standby power before the generator was ready. So if that happens, the controller sees the voltage collapse and throws the fault. The fix is simple. Remove the load, start the generator clean, then reconnect once the voltage is stable. Now, I know this isn't a follow along and fix it in real time kind of video. These codes take tools, test leads, and patience, but I've linked a simple guide below, so pull it up on your phone, your tablet, or whatever works best while you're in front of the generator doing the real work. If you've gone through all of these tests and still don't have a solid answer, don't be afraid to call in a trained tech. These systems are layered, and sometimes you just need fresh eyes or a service tool you don't have in the toolbox. There's no shame in calling back up. If this video helped you understand your undervoltage codes better, reach out to share your experience below. Your insight might help the next homeowner or tech out there scratching their head. And if you want more generator walkthroughs like this, go ahead and subscribe. We're just getting warmed up. And that's a wrap on the undervoltage codes. We followed the manual, but we added real-world logic you only get from being in the field. And remember, when in doubt, get it checked out. Stay sharp, stay hands-on, and we'll keep you powered no matter what. I'll see you in the next one.